if you look at our handout, we've pretty much covered everything except one little thing. And that last little thing is where we're at here. Section 6.5 is going to be the sum and difference of cubes. So 6.5 and 6.5. That's the last little piece we have to take care of. So let's do that. Let's do that. Sum of cubes and the difference of cubes. Okay, so let me write down a couple formulas. A cubed plus b cubed and a cubed minus b cubed. And I'm going to write these down except for the signs involved. A, b, a squared, ab, b squared, and then a and b, a squared, ab, b squared. So far, are these looking kind of similar? These two formulas look similar? Yes. Now, what we're going to need to fill in, what you're going to need to remember, is the signs that go between these two. So the signs follow a nice little pattern. These two first signs are always the same. So S. What do you think the O stands for? Opposite. And the last one is always positive. So your signs for these formulas are same sign, opposite sign, and always positive. See if you can't fill in the signs down here for the second formula using that same idea. So that same mnemonic helps you out in both formulas. Same sign, opposite sign, always positive. So, George, what would they be? Good. So minus, plus, and plus. One other thing that can help you out with the signs, and it's actually, it saves me from making mistakes many times, and it is one negative sign per customer. So if you look at these formulas, each of them have exactly one negative sign. So if you accidentally write something down that has two negative signs or no negative signs, there's a mistake. Each of these formulas has one negative sign. Now, as far as the formulas themselves are concerned, we're going to approach this a little bit different. This mnemonic is great for the signs, but we need to figure out how those terms work in between. So we'll start with problem number 18. B cubed plus 216. Well, if you're given something like this to factor, start by looking at your sheet and you look for a GCF. Is there a GCF here? No, there's no GCF. Then you say, all right, well, there's two terms. All right, so there's two terms. It's not the difference of squares. It's not the difference of cubes. It's the sum of something. But look at the terms involved. Are those terms squared terms or cubed terms? Cubed. In fact, on the left-hand side board, in addition to a very generous and thoughtful person who gave you the first 20 perfect squares, somebody also gave you the first 10 perfect cubes. So look at the left-hand side board. What do you cube to get 216? 6. So it's always going to be a binomial times a trinomial. And the first two things we need are going to be what do you cube to get this and what do you cube to get this. So it's 6 here and a b here. We'll worry about the signs in just a minute. So okay with the binomial part. The binomial gets followed by a trinomial. And what I'd like you to do is this. We're not going to try and remember this formula kind of verbatim. You could. There's nothing wrong with it. Instead, what I prefer to do is use these two to come up with these three. How could I do that? How could I use these two to come up with these three? Well, I could take the first one, b times b, and get b squared. I could take the second one, 6 times 6, and get 36. Now I've multiplied this by itself and this by itself, so I've got two of these. I know I need one more. What other combination of things could I do? Good. Yeah, multiply these two together. B times 6, and as Mara wrote it very nicely, 6 times b. Put the number part first. Now we take care of the signs. So, same sign, opposite sign, always positive. Karanja, what signs are going to go in here, please? Good. And that's it. There's your answer. Yes, sir. Say again? We'll tell you what. How about if we check it by multiplying it out? Would that work? Well, I took this term times this term. So b times 6, and I just wrote that in the order of 6 times b. But it comes from multiplying these two terms together. So that's the way that we get all three terms. You square this one, you square this one, and then you multiply these two together to get the middle term. But let's check it out. Let's take b plus 6 times b squared minus 6b plus 36. Let's see what happens when I multiply that together. B times b, b cubed, minus 6b squared plus 36b. Then I'll distribute the 6. 6b squared minus 36b. 6 times 36 is a plus 216. When I add those together, what do I get? What happens when I add these together? Those cancel. These cancel. Not much left, is there? B cubed plus 216. So it checks. Let's practice these a couple more times. Let's jump up into something a little bit more challenging. Problem number 40. 27x cubed minus 1000 y cubed. Again, think about your sheet. What's going to happen on the exam and what we're going to do later on is some practice of a bunch of random terms. But you're going to have this steps to factoring thing in your mind. You're always going to look for the GCF. After you look for the GCF, if there isn't one, then you're going to count, gee, there's two terms. There's not too many alternatives to factor two terms. It is the difference of two things. So it's not the sum of squares or the sum of cubes. Next, let's see if it fits into one of these. Difference of squares or difference of cubes? Yeah, that's looking like difference of cubes to me. If the cube numbers here for the exponents weren't enough, then the 27 and the 1000 should be. So what do I cube to get the first term? 3 and an x. How about the next term? Micah, what do I cube to get the next one? 10y. Good. So 3x and 10y. What we want to do is use these two terms. I'm sorry, that's not in focus here. There, that's better. Use these two terms to get these three terms. We're going to do the same thing here that we did with problem number 18. Take the 3x times the 3x. Multiply this term by itself. What do I get here? 9x squared. And then the 10y times the 10y. That's going to give me this term, 100y squared. Sydney, I need one more term here. How am I going to get that? All right, 3x times the 10y gives me 30xy. Big E, I'm almost done. What's the one thing left I need to do? The signs. So can you help me out with the signs? Good. Negative, positive, positive. Same sign, opposite sign, always positive. Let's do one more like that. Maybe two more. Let's try problem number 28. (64m cubed) plus 343n cubed okay. Your turn for one. You might find the list on the left-hand side board pretty handy when you're looking at these. It's not going to go anywhere, but it is, I'm not saying you have to memorize it, but it is a good idea to have some familiarity with these numbers. So when you see 343, you're like, oh, yeah, that's 7 cubed. Stuff like that. Helps you out. So the sticky point for a lot of you seems to have been making sure you get the right number to cube to get 64. 64 is on both lists. It's kind of a special number. 8 cubed, or excuse me, 4 cubed is 64, and 8 squared is also 64. But we want to pick the number that's coming off of this, the perfect cubes list. So that number would be a 4. 4m, and then 7n. Once you got those two, the rest of it is just using those two to find the remaining 3. So 4m times 4m, 16m squared. 7n times 7n, 49n squared. And then 4m times 7n would be 28mn. I'm sorry I have to write so small there. I didn't leave myself enough room. Last but not least, we need to fill in some signs. Same sign, opposite sign, always positive. Plus, minus, plus. Cool. Should we do one more? Or are we good on these? Good on these? Okay. For homework, try 17 through 29, 37, 41 through 43. And then if you need some review problems, the review problems in this section would be 49 through 53, 65 and 67. So some extra review problems there for you. Keep in mind that you could do problems, or you could get problems that ask you to, say, factor out a GCF first, like problem 44. If you had to factor out the GCF first and then factor as the difference of, or sum of cubes, that's fine. Nothing wrong with something like that at all. Good luck.